We're in section 10.8. This is the system of linear equations. Very similar to what you did in Math 100. It's the foundation of what you need to know. Excuse me 1 second. I gotta turn my phone off. So it's a section that you need to know to move forward. And it's sort of like the introduction to linear systems. So we have two equations, two unknowns. Again, just to review what you did in Math 100. Typically, we have a couple different techniques. One technique is to graph the two lines and find the point of intersection, if there is one, right? There may be more than one point of intersection, all right? There may be no points of intersection. We talk about terminology about what consistent and independent means, what about inconsistent means, and what dependent means, all right? We went through a bunch of examples, maybe not a bunch of them, we went through a few examples to illustrate what you were taught in Math 100. Okay, so the point we're at now, hopefully you're ready to go out on your own and review this material after studying it. So what we're going to do is go to the supplemental activities and we're going to start doing the problems now. It's going to be a short, very short session on this. So I'm going to switch to the whiteboard. And we'll talk about doing problem number one. And let me just grab that problem here. And I'm going to talk about what we want you to do if you were given this instruction on the problem. It says solve by graphing it. All right. So if you're asked to graph it, you're going to have to graph it. So I want to graph one line at a time. And to do that, you pick a line to graph. And again, this is rough. I'm not going to say it's terribly accurate. I want to graph this line over here. So I'm going to make a table up for this line. And I'm going to say x is 0, y would be equal to 2. Let's see, if y were 0, x would be equal to 3. We'll put this down. 1, 2, 3. I'll put the point down for you. And the other point's going to be 0, 2. Now, again, I'm not going to say this is the most accurate line in the world, but it's one that's going to represent, abstractly what that line is. Let's do the next one. And again, looking at it, I'll take this one, I'll do it in blue. And I'll put this table over here. And let's take a look at that. I'm going to say, looking at it, I'm going to say y to be, or x to be 0 and y to be -5. All right, let me see. 1, 2, 3, 4, 5. Over here somewhere, okay? And another point, and I'm going to pick x to be, let's see. I'm trying to think about it now. I want to get that I don't want a fraction, right? Let's try -3. That would give you 9, and that means y would have to be 4. Let's see. 1, 2, 3, and then up 4. And I'm going to say right about here, somewhere about. Let's draw through. Okay, I can't say this is true. I'm just looking at it, and I'm hoping that this is the point of intersection. It may not be. So what do I think the point of intersection is? I think it's going to be -3, 4. Well, I know it works here, right? I know it works there. Again, what do I mean by that? Works over here. Definitely works there. What do I mean by that? That would give you 9 -4 = 5. But I have to verify that it works here. Let's see if it does. What does that give you? -6 + 12. That, of course, equals 6. This is the point of intersection. All right. So let's go to number 2. And number 2 says something different, by the way. It says solve by substitution. And again, we're just reviewing the techniques that you've done in Math 100. That's all we're doing. So if you're going to solve by substitution, what you do is pick one of the two equations and solve for either x or y. I'm kind of looking at it, and I'm going to say the second equation that I could solve that for y pretty easily. What do you get? minus 3x minus 5 equals y. And then what do? You're going to take this, which is y now, and substitute it into that equation over here, this equation here. Let's put that down. What do you get? 2x plus 3. What's y? It's minus 3x minus 5 equals 6. Let's put this down. 2x minus 9x minus 15 equals 6. Let's see. 2x minus 9x is minus 7x minus 15 equals 6. I'm going to add 15 to both sides. That would be 21. X would be equal to minus 3. Now, that's certainly what x is. What's y? Well, it's right up here. And what's y going to be to? Well, it's going to be minus 3 times x, which can be 9 minus 5, which is 4. So we have our point of intersection. X is minus 3 and y is 4. All right, that's by substitution. Let's go to the next one. And what's the next one going to be? Solved by the addition method. All right, let's put a box in this one over here. And we're going to go for addition. What the addition method will really want to do is we want to make sure that, certainly we want to make sure the equal signs are lining up, and they are. Furthermore, it's great if everything else lines up, like the x are lining up, y's are lining up, and the constant lining up. Unfortunately, if I were to add these two equations together, there would be no elimination. So the addition method is also called elimination. So I need to select someone to eliminate. And the way I'm going to do this over here is I'm going to tell you who I'm going to select. I'm going to select the y to get rid of. And why is that? Well, the least common multiple between 3 and 1 would be 3. So I'm going to multiply the second equation by 3. And what do you get? I'll put that down for you. You get 2x plus 3y equals 6. I've done nothing to the top equation. The bottom equation I multiplied by 3. So you get minus 9x minus 3y equals 15. Then what we're going to do is add them together. Well, if you add them together, what happens, again, it's the reason called the addition method. It's also called elimination. We want something to eliminate, and it does. The y's disappear. What do you get? Minus 7x equals 21. This should be very familiar to you. And x is equal to minus 3. Now, let's say you want to eliminate the x's in the problem. All right. Let me cross this out. We're done with that. And what would you do over there? LCM between 2 and 3 would be 6, right? So I multiply the top by 3 and the bottom by 2. Let's go through that. And what do you get? 6x plus 9y equals 18 minus 6x minus 2y is equal to 10. Add the two equations together. Something does eliminate the x's, which was my goal was. You would get 7y equals 28. Divide both sides by 7, and you get y is equal to 4. So I have my solution again, minus 3, comma 4. So we did this by graphing, we did it by substitution, and we did it by elimination. And of course, we're getting the same answer. Which one's the easiest technique? That's up to you. Some people say, oh, graphing's easy. Graphing's easy if you're good at it. Substitution's easy if you can solve one of the equations for a given letter. And elimination works really nicely. I'd say it's probably, in my opinion, it's the simplest one to do. All right, that covers that. It was a very short section. Just to review what you did in Math 100. I do want to go back to the notes, though, and I'll do another screen share with you. And I want to talk about the technology. All right, so I'm going to go back to Sage. And I'm going to talk about using technology to solve problems, linear systems. All right, so let me type in reset. Again, we've been doing this for some time now. It just clears out the memory. I'm going to define two variables now, x and y, var x and y. And then I'm going to try to solve. And I want to point out what I'm solving, a system of linear equations. And that's going to be a listing. And the first one, I'm going to go back over notes and I'll point out what we're looking at over here. It's 2 times x plus 3 times y. The double equal sign is an equation. That's the first equation. I notice they put that in parentheses. I'm not going to do that. and comma. The second equation, I'm just looking at it, is minus 3 times x minus y equals 5. Again, the square bracket saying it's a listing of two items, and I want to solve for x and y. All right, so it gives me the answer minus 3, 4. Now, where'd that question come from? It came from this over here. Is it the same thing? Yeah, two equations. The first equation is 2x plus 3y equals 6. The second equation is minus 3x minus y equals 5. And we're solving for x and y. And what does it tell me? It tells me x is minus 3 and y is 4. Exactly what we expected. Again, we did it 3 different ways. We did it by graphing. I find it to be the most difficult, so I'm not good at graphing. We did it by substitution. We did it by the addition or the elimination method. And we also use Sage code to get that. All right. So that covers the introduction to linear systems. Granted, this is nice software. You want to start learning to use software if you can. We're not going to test you on it, though. If you move forward, though, whether at Essex County College or at NJIT or any other school, they're going to have an expectation that you're capable of using what's known as a computer algebra system. And Sage is a good example of that. Thank you.